If you are a computer science student hoping to secure a placement by memorizing Python syntax and relying on basic autocomplete, you are training for a role that is rapidly being phased out. Significant shifts are already visible at the top of the market, where traditional entry-level engineering pipelines have effectively frozen. Marc Benioff, the CEO of Salesforce, stated this week that his company has almost not hired new engineers in 2 years. Instead, autonomous AI coding agents have begun handling the high-volume workload that once defined the junior developer's day-to-day. This aligns with a forecast from Anthropic's leadership regarding the trajectory of the software engineering title itself. They predict that the traditional software engineer designation could be replaced by builders and managers as early as the end of this year. When both the major enterprise buyers and the AI developers themselves signal this level of displacement, the market's demand for manual code production begins to contract, altering the requirements for every computer science graduate. We are seeing the obsolescence of a specific role, the Copilot Typist. The typist's workflow is linear and reactive. They use AI as a glorified spell checker, feeding it single prompts and pasting the output without analyzing the underlying math or system architecture. Because this process requires zero system awareness, it is now the first part of the stack to be entirely automated. The emerging standard is the AI governor. The governor does not focus on manual syntax. Instead, they act as an orchestrator, managing a network of specialized autonomous agents. This creates the automation paradox. As AI generates more boilerplate code, the demand for human validation of foundational architecture becomes more critical, not less. In this model, the AI handles the execution of the code, but the human engineer assumes full architectural accountability. To understand the governor's role, we have to look at how a multi-agent workflow actually functions. Modern engineering requires coordinating these specialized nodes, each assigned to a different phase of the software development lifecycle. One agent is dedicated solely to database planning and data relationships. A second agent handles the API generation, building out the communication endpoints. A third agent runs the tests, checking the code for immediate execution errors. These agents must communicate synchronously, passing data packets back and forth in a continuous loop to ensure the system stays integrated. The human governor intervenes at the intersections of these communications, directing the high-level design and performing quality assurance. Because complexity scales exponentially when multiple agents are involved, the system requires a tier of oversight that a simple typist cannot provide. There is a common assumption among students that because AI generates code so fast, the need for computer science theory has diminished. The sheer volume is actually the hidden danger. An AI agent can generate a complex 1,000-line deployment script in seconds. If you lack the deep theoretical knowledge to validate that script, you are effectively flying blind, unable to see the structural flaws hidden in the volume. For example, an AI might generate an efficient-looking script that contains a subtle vulnerability in its deployment logic. An operator who lacks architectural training will miss this, approving a script they don't fully understand. The resulting failure isn't isolated, it cascades, corrupting the database and the API layers, leading to a total systemic collapse. AI can execute tasks, but it cannot compensate for a lack of foundational engineering knowledge in the person who prompts it. Rapid execution without theoretical validation scales errors at an industrial rate, turning an untrained operator into a significant security liability. We see this most clearly in how machine learning systems are deployed. A frequent indicator of an unskilled operator is the failure to distinguish between different architectural requirements during system design. On the left, we have System A, a basic neural network used for simple tasks like routing search queries. This requires relatively low compute power and a straightforward architectural footprint. On the right is System B, a multimodal enterprise agent utilizing a deep learning architecture. System B involves massive compute dependencies and entirely different deployment risks compared to System A. Because these two systems serve different functions, treating them as interchangeable during the planning phase leads to immediate technical failure. When a candidate confuses these two, a senior architect knows immediately that the person is just repeating keywords without understanding the systems. Failing to identify architectural complexity is the fastest way to prove you are a typist, disqualifying you from high-level orchestration roles. Adapting to this shift requires a complete change in how we study engineering. Sitting in a classroom and watching an instructor type out boilerplate code is no longer a productive use of time. The new standard focuses on project-based learning and a flipped classroom model. You should be working in advanced development environments, treating the interface as a systems dashboard rather than a simple text box. Let the AI generate the basic data structures. That is the least valuable part of your day. Your focus must shift to auditing that output, reviewing for security risks, managing system complexity, and ensuring the agents are communicating logically. Educational value now comes from the ability to rigorously validate the logic of an autonomous agent, not from the ability to write the logic yourself. To function as a governor, you must adopt a different daily professional workflow. You must be proactive in hunting for vulnerabilities within AI-generated scripts. You must manage the compounding complexity that arises as you add more agents to a system. And you must verify that your agents are actually communicating with each other as intended. This is a slightly psychological transition from hands-on keyboard creation to high-level systems governance. Manual coding is no longer the core act of engineering. In this landscape, the successful builder is defined not by their typing speed, but by their grasp of foundational computer science theory. To survive the 2026 tech market, you must abandon the idea that code generation is the goal and fully embrace the demands of architectural orchestration.